A few months ago, we had a content pipeline for security videos. Research Node wrote a short CVE summary early. It was wrong in a small way. Affected version range was guessed from a stale advisory. No alarm fired. The thumbnail node used that summary to choose the hook. The description node cited it like confirmed fact. By the time a human reviewed the package, 3 downstream assets agreed with each other, because they all drank from the same poisoned well. That is shared state rot. Shared state is useful. In graph-shaped agent systems, you often need a blackboard. Findings, decisions, file paths, task status, artifact identifiers. The naive version is just a dictionary that every node can read and write. That feels flexible, until flexibility becomes ambiguity. One node writes a hypothesis. Another node reads the field name and assumes it is verified. A third node formats it for a user. The bad part is that garbage does not announce itself. It compounds quietly. The state object starts as coordination, then becomes an unreviewed database of claims, half-facts, and stale decisions. The pattern is opinionated. Treat shared agent state like a small database, not a scratchpad. Every field has a type. Every field has an owner, meaning the node or subsystem responsible for making that field true enough to use. Every node gets an explicit write-allow list. If a node tries to write a field it does not own, or is not allowed to update, the state layer rejects it. Every successful write gets stamped with provenance, author node, timestamp, and ideally source identifiers. You are not preventing all errors. You are stopping anonymous errors from becoming shared reality. Mechanically, put one state gate between every node and the shared object. Step 1. Define the schema. Field name, data type, required or optional, owner node, and maybe allowed status values. Step 2. Define the write matrix. Node by field, yes or no. Step 3. When a node returns an update, do not merge it directly. Run validate field exists, validate type, validate node may write it. Validate required provenance if the field represents an external claim. Step 4. Stamp the write with author node and timestamp. Step 5. Commit or reject. Rejection should be loud, structured, and visible in traces. Take the CVE content pipeline. The research node may write CVE summary and source URLs. The verification node may write severity status and verified claims. The thumbnail node may write thumbnail brief, but cannot edit CVE summary even if it wants a stronger hook. The description node may write description copy, but it must read verified claims for technical assertions. Now, the early mistake changes shape. If research writes a stale version range, the field is stamped research node at 1014 with source advisory A. When verification rejects or updates it, replay shows the exact bad write. Downstream nodes no longer get anonymous truth, they get typed fields with lineage. This is not magic. A string can validate and still be false. A permitted node can still make a bad call. Provenance tells you who wrote something and when. It does not prove the claim is correct. Another failure mode is schema drift. If every experiment adds 5 fields, your state becomes a junk drawer with types. Too strict is also painful. If only one owner can update a field, that owner can become a bottleneck. My practical rule: start strict on claims, user-visible content, file operations, and decisions. Be looser on scratch calculations, but keep scratch fields clearly named and short-lived. This sits right after context management in the graph tier. Context rot is what happens inside one model call or one rolling conversation. Shared state rot is the larger sibling. One node's guess becomes another node's ground truth. Typed permission state gives orchestration a contract. Verification nodes know which fields to inspect and which provenance to distrust. Budgeting gets cleaner too, because you can limit how often expensive fields are rewritten. Later, when you add retries, human review, or replay, provenance is the difference between debugging a system and staring at a blob. Pick one automation you already run. Open its shared state object, memory document, database row, or task JSON. List 10 fields that downstream steps read. For each one, write the type: string, boolean, enum, list of URLs, artifact identifier, whatever is real. Then write the owner node. Then make a tiny matrix. Rows are nodes, columns are fields, cells are yes or no for writing. Finally, add one guard before merge. Unknown field, reject. Wrong type, reject. Unauthorized writer, reject. You do not need a framework. A 40-line wrapper around state updates is enough to feel the difference. 3 beats to keep. First, shared state turns guesses into inputs, so do not let it be an untyped blackboard. Second, type every field and give each node an explicit write-allow list. Third, stamp every write with author node and timestamp, so replay blame is possible when the graph lies with confidence. The trade-off is more ceremony, but the payoff is a loop you can inspect under stress. This is loop engineering, reliable agent loops with stop conditions, verification, state, budgets, and guardrails. New loop engineering episode daily on this channel.